Welcome to the notes on quotient rules and zero exponents. So let's take a quick look again. Remember that a exponent has a base with raised to some power. All right. Again, we call the number on bottom the base, and we call that number on top. Well, that's our exponent. So just be careful. A couple examples that you can tell which is the base, which is the exponent. When I say 3x to the fifth, which base does that exponent of 5 go with? Well, that base is just the x, okay? It's not the 3, okay? 3 is a base, but its exponent is 1 right there. So be aware of that. And then we talk about negatives, okay? If I have negative 3x to the fifth, or maybe, all right? Again, the exponent, the x goes with the 5 goes with the exponent. Okay, just like if I just got rid of that x and I just put negative 3 to the fifth. Again, the base for the exponent of 5 is just the 3. It's not the negative sign in front of that. It's just the 3. You don't include the negative only if it's inside the parentheses. That time the base would be a negative 3. Okay, otherwise it's just the number that goes with the exponent, not the symbol that is in front of it. So keep that in mind. So now we know that. Let's take a look at a quick example here. Let's say I have x to the fifth, and I've divided it, because that's what quotient means, x to the third. So let's break this apart. So if I have x to the fifth, that really equals x times x times x times x times x. And that's really going to be over, all right, x to the third, which is x times x times x. Now we know about canceling out, so let's take a look at if we cancel that out. We'd be left with those would be gone, those would be gone, and those would be gone. Well, what would we be left with? We'd be left with just x squared on top. So the answer would be x squared. This works every time, but what people noticed is another way to get that is if I subtracted 5 minus 3, I would get x squared, and that's exactly what the quotient rule says. If you have positive integers with a common base, again, it has to have that common base, then you can just subtract the exponents, and that will give you your answer. That's how the quotient rule works. So here's some quick examples. Again, common base of x. If we look at the first one, then you just take the 5 minus 2, which is 3. So this answer would be x to the third. Again, common base of 4. So I know that 4 is going to be in the answer. And just take 7 minus 3, which is 4. So that's 4 to the fourth. You can keep it as 4 to the fourth, or you can make that into a whole number. Okay, C, again, we've got a common base. It is the negative. That it stays, all right, in the answer. So it's negative 3. Again, 5 to the second power is 3. So negative 3 to the third. You type that in a calculator, and that will give you can keep it like that, or just final answer of negative 27. A couple more examples. D, okay, now if you look at D, those are not common bases. So we cannot cancel anything out. So the final answer would remain the same. It would just be s over s to the second power over t to the third power. You can't cancel out there. Again, you have to have that common base. And you look at the last one here. Okay, now this one kind of helps to break apart, but it's really 2 times x to the fifth over x times y to the second over y. Well, remember with these, there's really an imaginary 1 there. So we subtract, we're going to have 2. 5 minus 1 is x to the fourth. 2 minus 1 is just y. So there's your final answer. So there's the quotient rule. Here's how it works with power of a quotient rule. Just like yesterday, if you have an exponent outside a set of parentheses, you have to distribute it to everything inside the parentheses, top and bottom. So in this example here, we got to distribute that exponent of 7, to top and bottom. So that's really m to the 7th over n to the 7th. It's that easy. Okay, another example right here. So that's going to be x to the third is going to be raised to that fourth power. I'll kind of show that extra step. And on the bottom, we're going to have that everything's got to get it. So we're going to have that 3. Every base down there has to get raised to that exponent. 3 to the fourth times y to the fifth to the fourth. And then you can see we have powers to powers. We've got to multiply those exponents. So when we do that, we're going to get on top x to the 12th Oh, on the bottom, we're going to have 3 to the 4th. All right, 3 to the 4th is really 81. And then y, 5 to the 4th, 5 times 4 is y to the 20th. So there is our final answer right there. Okay, last thing we'll take a look at is zero exponent. It's really easy, but we'll show you why it is. Let's take a look at a quick example. If I have x to the third over x to the third, well, let's use our quotient rule. How do we figure out that answer? Okay, well, it's x times x times x over x times x times x times x. It's all going to cancel out. Or you're going to say 3 minus 3 is x to the 0. But 0 isn't 0. It's the same thing top and bottom. When everything top and bottom cancels out, we know that it actually equals, all right? Actually, it equals the number 1. So that's why anything to the 0 power simply equals 1. Knowing that makes these problems really easy. Anything to the 0 power is just 1. 3 to the 0, 1. We've got all this stuff going outside here, but to the outside, it's raised to 0. Well, again, when you distribute that 0 through, that's all going to become just 1. A negative 5 to the 0, still 1. This one, still going to become 1. Oh, yeah, we've got a negative in front, but negative 0. Oh, excuse me. This one is actually negative 1 because the 5 to the 0 is 1, but then we do have that negative sign in front. So be aware of that. Big difference between C and D. Almost made a quick little mistake there. At the end, fraction, it's to the 0 power, still 1. This one, be careful, kids. Again, only the base that goes to 0 becomes 1. So it's 4 times 1. So this answer would be 4. So there you have our properties of the quotient properties of exponents, and then 0 as an exponent.